Hello. Today I'm going to talk about the November 2025 Jane Street puzzle called Shut the Box. In this one, we're given this big square of individual squares, and the idea is that we're going to cut out part of the squares inside here, and then the remaining squares we're going to fold up into a rectangular box. So not necessarily all the the sides of the box have to be the same size. It's just a rectangular box, and there's some extra rules where I think it's like the square. The numbers with squares have to be opposite another number with square, like parallel to the faces of the box. And some other rules here, if you can see this image, the number indicates how many squares, including itself, will be included in the final box. Um, so, for example, for this number 5, out of all of these 9 squares surrounding it, including itself, 5 of those will be part of the final box, right? And then the arrows are, I think, the most helpful hint. They tell you the direction of the closest squares that will be part of the final box. So, for example, here, if we look at these two, the squares that will be closest to the final box are in this direction and in this direction, but not in this direction and not in this direction. So I think also the arrows are not part of the box. I think that's right. Yeah, I don't think the arrows are part of the box. Let me. So these cells are not part of the box. There we go. Some cells have been labeled with arrows. So hopefully those rules make sense. So again, we have this big square made up of little squares. We're going to cut part of it away, and we're going to fold up what's remaining into a rectangular box. Um, and you have to end up with one piece, right? So you can't have that you cut up like you cut it in half and you end up with two pieces because those don't make up one box. So basically, all of the bits that are left in the box have to be connected somehow. If you think of it like a graph, it has to be a tree, right? And also without cycles, you cannot have. Obviously, if you're trying to fold up something that has a hole somewhere, it's not going to create the full box, right? So you cannot have cycles. It has to be like a tree graph structure thing, right? Um, so I don't think I'll draw out the entire box and how I think about it. But we can start just like from the fundamental first principles of how you would go about solving this. So as you know, the squares. Let me undraw that. Right, these are not part of the box, right? But then the arrows, moreover, provide. I think right away you can get a lot of interesting information from the arrows. So, for example, let's look at this arrow, this box with arrows, right? So, this box with arrows says that your closest, um, your closest arrows, right, are below you and to the right. So, um, right, this already gives you very valuable information because you can deduce that that this square is not part of the box, and this square is also not part of the box, right? Because in the optimum case or in the maximum case, right, this square is part of the box and this square is part of the box, but the arrows only point to the right and left, right? Which means that you can deduce that these two squares are not part of the box, right? And so right away you can go through like every single arrow here, right? And just pretty much, all the ones that I'm coloring black, I know for sure they will not be part of the box, right? So this will not be part of the box. This is not part of the box. This is not part of the box. This is not part of the box, right? This is not part. Actually, yeah, that's correct. This is not part of the box, and so I can literally just keep on going here, and it's like very tedious coloring all of these in because there's so many arrows. Um, so this is not part of the box. This is not part of the box, and as I told you before, right? Um, you're not going to end up with several pieces of paper. You're going to end up with one piece of paper that you have to fold, right? And so if you look at these two squares right here, right, we've already sort of shut them out, right? There's nothing that could connect them to any of the other squares on the paper, right? So therefore, you have to deduce also that these two squares are also not part of the box, right? So I think I think that's pretty much enough to solve the problem. Like I said, I don't really want to go through drawing the entire sheet of paper. At the end, there were like, when I was doing it, there were a couple like ties, or in Minesweeper, when you're not, you can't 100% drive in your mind, like what's the square without a bomb. It's the same thing here, right? There were like some up here, like the 5 and the 7, where it was unclear which of the squares were part of the box and which were not. Like it could go either way, given the information that I had on hand. So what I did there is I left them as, unsure, and then I pretty much just printed out the thing. And I don't think I could have done this in my mind, where I just look at it and say, this is how it folds over each other. But I basically just printed it out and folded it with tape, and I got the answer. So I think that's pretty much it. Again, let me say the fundamental principles at play here, right? If you have an arrow, right, like this, you know automatically that this square is not part of the box, right? And furthermore, right, for example, if you look at this thing right here, right, if you somehow deduce that this is not part of the box, right, then you also deduce that this thing is also not part of the box. Why? Because if this were part of the box, right, then this is an equal distance. If this is part of the box and this is part of the box, then the arrow should point both up and sideways. So it shows you the closest direction. And when there's a tie, the arrows should go both ways, right? I should have an arrow pointing up and an arrow pointing sideways, because both of those are closest, they're equidistant. Therefore, if I know that this is a part of the box, right, I can conclude that this one is not part of the box. And so, just playing around with that, you eventually get to a state where it's almost clear. You print it out, you cut it out, and then you try to tape it. And that's how I got the answer. I think that's it. Pretty simple problem. Yeah, that's it.